Hello students, this is a quiz review for the Unit 4 quiz that I'm giving at the culmination at the end of Unit 4. We did the do now together in class, and we did this class discussion together, but I wanted to run through the answers for some of the problem set problems just in case you didn't get that in class. For the first problem, it was an error analysis problem. It told us 3 more than twice a certain number is 57. So we're going to annotate that, 3 more than twice a certain number. And remember, all of these things mean something in math, is and also 57. So what we can do is we can take this sentence and turn it into an equation. And here's what all these pieces mean. The 3 more than means add 3 to the end. Twice means multiply by 2. A certain number indicates a variable. In this case, we'll use x. Is an equal sign, and 57. That's pretty self-explanatory. Now we're going to take this and put it together into an equation, which looks like this. 2x plus 3 is equal to 57. The question actually asks us to state whether student A is correct or student B is correct, and if neither is correct, to justify the answer. Student A is incorrect because of one choice that student A made. Student A decided to multiply the entire quantity by 2, where it doesn't say that. So in response, you could say that student A decided to multiply the variable and the 3 by 2. In the problem, it's stated to only multiply the variable by 2. Well, that's pretty messy, so I'm going to try to clean that up. Here we go. And then for student B, it's fairly similar, except they got one different thing wrong. For student B, you can see that they multiplied by 3 and they added 2. So for student B, the problem was not choosing to multiply the whole thing by 2, but not understanding the vocabulary. So student B thought that 3 more than was supposed to multiply by 3, but in fact it means to add by 3. And they also thought that twice indicated adding by 2, or addition. So now you see that we've responded to student A and we've responded to student B. This is our correct equation, which is neither student A nor student B. Now that we've done a little bit of error analysis, we can go on to the next question. Next question says the larger of 2 numbers is 4 times the smaller. So the larger of 2 numbers, that's one item. 4 times the smaller, that's another item. If the larger number, whatever that is increased by 12, and you know in annotation we should add in our notes, increased by 12, of course, means plus 12. The result is, and you know that result is something that we indicate with the equal sign. So the result is, that's the equal sign here, 5 times, and we know that times is one of the keywords that we use for multiplication. The smaller number, and the smaller number we haven't designated just yet. The question is asking us to find the 2 numbers. Whoa, I don't know what that is. It's asking us to find the numbers, so we're going to circle that part. Just like in any word problem, I ask you to set up some sort of structure to help you solve the problem. In this case, we're going to use let statements. The first step in solving a problem is admitting that you have a problem. So I don't know either of these numbers, so I'm going to admit that I have no idea what the smaller number is. Let x be the smaller number. And that's me admitting that I have no idea what the smaller number is. However, if I say x is the smaller number, it says the larger of 2 numbers is 4 times the smaller. So that means the larger number is going to have to be 4 times x. Pretty straightforward. Now we're going to take the equation that's written out for us in words, and we're going to write it down in letters and symbols. If the larger number, that's 4x, is increased by, that's plus 12, that's 12, the result is, 5 times the smaller number, x. Now that we have an equation set up, we can solve it using the same exact properties that we've used to solve every other equation we've ever done. We're going to subtract 4x on both sides. That would be a 4x. And then we've solved the equation because 12 is the only thing left on this side, and 5x minus 4x, of course, is just x. Our answer is x equals 12 for this equation. It says to find the numbers, though, so we need more than just x. We know that the smaller number is 12. In order to get the larger number, we're going to have to multiply that number, 12, by 4. So 12 times 4 is 48. Done. Moving on to question number 3. Marilyn's algebra teacher assigned this problem for homework, and he made an error. It says to find 3 consecutive even integers. Now, before even setting up this problem, remember what even integers are. They're integers in which they skip by 2 every time you go to the next one. If I told you my favorite even integer, which is 24, the next even integer would be 26. And of course, between 24 and 26, there's a jump of 2. So if I signified my favorite even integer by x, I would need to necessarily jump by 2 to get the next even integer. So I'm going to represent that by x jump by, or plus, 2. So now that I represented my first even integer and my second even integer, in order to get to the next even integer, I would have to jump again by 2. If I was signifying that with numbers and symbols, I wouldn't be able to say x plus 2 again. I would have to say plus 2 plus 2, or in other words, x plus 4. I notice in Marilyn's setup, however, that they used x, x plus 1, and x plus 2. Your answer to this question, then, your response to Marilyn, would have to be that they didn't use the correct variables. They used x plus 1 and x plus 2, whereas they should have used x plus 2 and x plus 4. Here's the response. And just like in any other academic conversation, we're going to be quite cordial during this. Marilyn, you used x plus 1 and x plus 2 as your consecutive even integers, but even integers skip by 2, not by 1. You should have used x plus 2 and x plus 4. So that x plus 1 should be x plus 2. X plus 2 should be x plus 4, because we're representing even integers. The rest of the work is correct, so if he replicated that same exact work using x plus 2 and x plus 4, he would get the correct answer. Next, finding 3 consecutive odd integers whose sum is 63. We're going to use let statements just the same way that we used in question number 2, but we're going to need let statements that represent consecutive odd integers. Here's what they look like. Again, my first step is admitting that I have a problem. If I'm looking for 3 consecutive odd integers, I have no idea what the first integer is. So I'm saying x is the first odd integer because I have no idea what it is. Now x plus 2 is the second odd integer, and I know that 2 isn't an odd number, but follow me here. If your favorite odd integer is 17, the next odd integer is 19. In order to get from 17 to 19, we had to add by 2. So if I say that x is my favorite odd integer, I would have to jump up by 2 in order to get to the next odd integer. I would have to represent it by x plus 2. And similarly, if I wanted to get to the next one, I would say x plus 4. So that's how we're setting up our problem. We need 3 consecutive odd integers, so we need one more let statement. There's our third let statement. X plus 4 is the third odd integer. Let's get rid of this stuff. And let's set up our equation based on the fact that the sum is 63. And remember, sum means add. I'm going to start off with x, and I need to add it to the second odd integer and the third odd integer. Well, the second odd integer is x plus 2. And the third odd integer is x, oh, I need a plus there, x plus 4. That sum, when I add x, x plus 2, and x plus 4, that should be equal to 63. The next step is to simplify the left side. We know that 3x plus 6, combining like terms, is equal to 63. Our next step is subtracting 6 from both sides. That should give us 3x is equal to 57. And our last step would be to divide both sides by 3. Our final answer should be x equals 19. Oh, that's 19. We can check our answer. 19 is an odd integer. It's asking for odd integers, so far so good. And we need 3 consecutive odd integers. So we need the numbers to be 19, and then the next consecutive odd integer, which is 21, and then the next one, which is 23. It checks out because x is the first odd integer, x plus 2 19 plus 2, which is 21, is the second odd integer, and x plus 4, 19 plus 4, which is 23, is the third odd integer. Next problem. This is a money problem that asked for using a table to set up, and we're supposed to show the other student where they made their error. The first thing we're going to do is annotate. We know that the parking meter slot receives dimes and nickels, 10-cent pieces and 5-cent pieces. Emptying the box produced 70 different coins, and their total worth is $4.85. It asks for how many nickels and how many dimes. So we're going to circle that part. Next, I'm going to set up a table that includes all of this information. Here's my super official table. It says nickels and dimes. The first thing we're going to write down is the quantity of each nickel and each dime. And we know that there's 70 coins in total, but we're not sure how many nickels there are and how many dimes there are. So we're going to go back to our old standby. I don't know how many nickels there are, so I'm going to have to define that as x. If I know that there are 70 coins in total, I know that the total number of dimes, well, it's not 70, but it's x less than 70. So my total, when I add these two together, should be 70. I added a note to help comprehend. 70 is the total number of coins that they found, but x is the number of nickels. So if I take the total number of coins and I subtract the number of nickels, I should get the number of dimes because there was only nickels and dimes. Next, I'm going to write down their current market value, how much the coins are worth. Now I added in some headings to make it a little bit more clear. The quantity of nickels and dimes is here. The coin value is pretty straightforward because we know that nickels are worth 5 cents and dimes are worth 10 cents. The reason we're writing it like this in decimal form is because our answer, which is $4.85, that's in the form of dollars, which has a decimal for cents. So we have to keep that unit consistent. Now, since we know the quantity and the coin value, we're familiar with the idea that multiplying the quantity times the coin value should give us the total value. So for example, if there were 5 nickels and there were 5 cents a piece, they would be worth 5 times 5 cents, which is 25 cents. So now we're just going to multiply these two as if they were numbers. I added in one more column that represents total worth. So now I know I'm multiplying my quantity times the coin value. So I'll take the coin value, which is 5 cents, and I'm going to multiply it by x. How easy was that? It's a little bit more difficult for this because we have a binomial for quantity, but not too difficult because we'll represent it as 10 cents times the quantity of dimes, which is 70 minus x. It's only a little bit more involved to write because it's a monomial, 10 cents, times a binomial, 70 minus x. Now I'm going to set up my equation using these values. So I've written in 5 cents times x, which is the total worth of all the nickels, 10 cents times 70 minus x, which is the total worth of the dimes. In total, when I add up the total worth of the nickels and the total worth of the dimes, I should get the total worth of all of the coins, which we were told is $4.85. Now I'm going to use the distributive property to clean up this side of the equation a little bit. I'm going to distribute 0.10 times 70 and 0.10 times negative x. Now when you do the distributive property here, you're multiplying 0.10 times 70, you get 7. 0.10 times negative x, you get negative 0.10x. Keep in mind, you should use a calculator when you're doing this multiplication to check yourself. Even myself, when I did this multiplication first, I actually had 0.7, not 7. So make sure you're getting this number 7. Next, I'm going to combine like terms. I combined 0.05x and negative 0.10x in my calculator, and I got negative 0.05x. The 7 stayed the same. Now I'm going to try to isolate the variable by getting rid of the 7. Keep in mind that this 7 is positive. Despite the fact that there's a negative sign right here, the 7 itself is a positive term. After subtracting 7 from both sides, I get negative 0.05x equals negative 2.15. Now all that's left is to do the multiplicative inverse property and divide both sides by negative 0.05. And at the end of that step, I should get x equals 43. That tells me that the number of nickels in this parking meter slot should be 43 nickels. In order to find the number of dimes, I should just take 70 and subtract 43 from it. Here's my final answer. We put it into a sentence form. The number of nickels is 43 and the number of dimes is 27. 70 minus 43 gives us 27. I'm going to show the next problem. I'm going to ask you to pause the video and try to set it up yourselves, and then when you come back from pause, I will show you the correct setup for this problem. So go ahead and pause it now. Alright, this is how the setup should be. We're representing quarters and nickels. Quarters I chose as x because it was just the first coin. Then I set up 20 minus x because there's 20 coins. Here are the costs, and here are the total costs. Now set up the equation and solve. Here's your setup, and here's your answer. Good luck studying, folks.